It's a solve equation. So we need to get x by itself in the end. Now, when you start a solve equation like this, cos 4x cos x plus sine 4x sine x equals 1, this is where that mostly memorized strategy comes in, because you have to recognize that on the left side of that equation, it looks like one of the formulas. So if I go, this is my alpha, this is my beta, this is my alpha, this is my beta, it matches up with the cos alpha minus beta formula. So you do that just because it does make the whole equation somewhat simpler. And we can simplify this, and we get cos 3x equals 1. And so as you get into higher levels of math, this is the kind of thing that happens. At the beginning, you have to recognize one thing that you could possibly do. Sometimes what you could do doesn't actually help you, but in this case, it simplified things. And then you have to reassess the question and say, what does this look like? What kind of question? Have we solved one like this before? It's a multi-revolution question. So then your brain has to switch to, how do we do multi-revolution questions? Well, we first change our domain. Ooh, fancy that there's not an equal sign there. Change our domain for 3x, and then solve for 3x 3 times around our circle from 0 to 6 pi. When is cos equal to 1? At 0, once around, and at 2 pi. Twice around would include 4 pi. 3 times around would include 6 pi, but 6 pi isn't included. So just 0, 2 pi, and 4 pi. Then you can solve for x by dividing each of them by 3. Nope, because this one gave us the domain here from 0 to 2 pi. If it was general solution, you could take those 3 answers and add 2k pi. Yes?
For a general solution, does this method always work, or do you sometimes have to use automatic?
This method would always work for general solution. You could find between 0 and 2 pi first and just add 2k pi. Okay.